Yes, sir.
Hi guys, good evening. Can you hear me?
Yeah, good evening, sir.
Yeah, thank you. So we'll start session. Let us start session. Yes, previous class about interpreter. Compare the difference is finished. Next, yes, word Java. Java depends on both compiler as well as interpreter. So this concept finished. Yes, now let us see Java features. Yes, how Java is independent platform. Okay, Java features in the independent platform. Yes, 1 second. Let me open my Java document. Yes, this is your Java document. Yes. Yeah, these basics completed in previous classes. Yes. Interpreter compiler yesterday topic. Yes, about Java. Java depends on both. Yes, Java depends on both compiler as well as interpreter. Yesterday discussed. Next features. Yes, features of Java. Let's see this. Now you can understand all these features here. Okay, the basics were discussed so that easy to understand now here. Yes, first one, Java is an independent platform. Yes, let us see how Java independent platform. See, Java, yes, is an independent platform. Yes, independent. 1 second. See, independent of platform. Platform means independent of platform. Independent of platform means yes, platform means base. So independent of platform means of independent of base. Independent of base. Independent of platform means independent of base. Yes. How Java made us independent of platform? That's the question here. Yes, how it is. How it is. So question is how it is. How Java made us independent of platform. Okay. Let us see this. 1 second. Yes. If anyone unable to, yes, unable to hear me, please rejoin the session. Just rejoin the session. Just rejoin the session. If anyone unable to hear me, rejoin the session. Rejoin the session. Just rejoin. If anyone unable to hear me, rejoin the session. Next, one more thing. Select audio while joining. While joining. Select audio while joining. Select audio while joining. Select audio. If anyone unable to hear me, rejoin the session. Select audio. Select audio while joining. Select audio. Select audio. Okay. Here this guy Vivek has to rejoin. Vivek has to resign. Yes. Yes. Here, independent platform. Yes. Yes. Independent platform. So independent platform means independent voice. Independent voice. How Java made us independent voice here? Yes. Question is how Java yes made us independent. Independent of platform. This is the question. How Java made us independent? How Java made us independent? This question here. Let us see how Java made us independent platform. Okay. Yes, this is a question here. How Java made us independent platform? Let's see. Yes, before going to this, let us see about exe file. You can understand very clearly about exe file. Yes, about exe file. About exe file. Okay. Yes, about exe file. See, here some question here. Some question is exe file prepared. Exe file question is exe file prepared on Windows page. Exe file prepared on Windows page. Question is here exe file prepared on Windows page. Yes. Can I run on Linux? Is the question. Yes. Any idea? Yes. Suppose exe file prepared on Windows page. Can I run on Linux page? This is question. Yes. Anyone? Yes. Can you answer this? Of course, I'll explain. Just I'm asking your idea. Just I'm asking your idea. exe file prepared on Windows page. Can I run on Linux page? Exe file prepared on Windows page. Can I run on Linux page? Yes, answer is no. No, we cannot run. Reason, 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 reason. Yes, what's reason for this? exe file, exe file is a voice dependent. Exe file is a voice dependent. Okay, exe file is a voice dependent. Okay, reason exe file is a voice dependent. Okay, right? Yes, exe file prepared on Windows page. Can I run on Linux page here? Can I run on Linux page? No. exe file prepared in Windows page. Can I run on Linux page? Answer is no, cannot. Reason exe file is a voice dependent. Yes, immediately question why? Why exe file is voice dependent? Is a question. Yes, why exe file is voice dependent? Let us see this. For this purpose, you should have this idea exe file idea. What is exactly exe file? Exe file kind of much. Okay. See, exe file prepared in Windows page. Can I run on Linux page here? So no, reason exe file is a voice dependent. Voice dependent. Why? Why exe file is voice dependent? Let us see. Yes, for this purpose, you must have the exe file knowledge. So what is exactly exe file? Exe file contains what? That exe file knowledge. Yes, you must have exe file knowledge. If you have that exe file knowledge, then easy to understand this one here. Exe file. Let us see how exe file is working. Let's see. Yes. Suppose, for example, here, for example, yes, C program exe. For example, here C program. Yes, C program exe file prepared on Linux base. Linux base. For example, C program exe file prepared on Linux base. Then, then, then it contains what? Let's see. C program exe file prepared on Linux base. Then it contains what here? That exe file contains what? Yes, Linux. That's Linux base. Yes, exe file prepared on Linux base. C program exe file prepared on Linux base. Then it contains what? See, yesterday's class, yes, we discussed about C program. ls. Yes, 1 second. Remove this star. Remove one star. Yes, remove dot opening. ls. Okay. Yes, ls. gedit test dot c. Gedit test dot c. So this is yesterday's program we discussed, right? See, this is our C program. Yes, compiling C program. Yes, this program, this is C program. So these are your codes. This is code, C program code. Next, std I would add header file. It's header file. Header file. See header file. Header file also developed in C language. C language header files developed in C language. C library developed in C language. Java library developed in Java only here. C++ library developed in Java. In C++ here. Okay, C library in C language. C++ library in C++. Java library in Java only here. So okay. So here std I would add a header file. Yes. For this file, there is a binary code. Behind of header file, binary code. This std I would add a header file developed in C language. So for that header file, some binary, it contains some binary code. It contains the binary code with all the functions. Okay, fine. Yes, now here, yes, gcc -c tested.c test.c. Yes, ls. See how it's working here. Yes, gcc, yes, -test.c. See, test.o file generated. What is tested.o file? What is tested.o file? Okay, what is tested.o file? Okay, see tested.o file. This tested.o file contains binary code for C program. The tested.o file contains binary code for C program. Binary code of C program means this part. Binary code. Binary code. This part. Binary code for C program. Binary code just for this part. This part convert into binary codes and write into tested.o file. Write into tested.o file. Right? It's fine. So tested.o file contains binary code for C program. Yes, after now gcc -o, yes, project exe file. Project exe file. gcc -o project exe file. Next tested.o file. Yeah, this result exe name. This result exe name can be anyone. This result exe name can be anyone here. Now run it. Yes. No. See this. Project exe file got it. Yes, how this project exe file creates? How? Yes, GCC C language compiler. Yes, taking object file. Yes, your program object file. Tested.o C program object means binary code. It's a binary code of C program. Okay. So the GCC C language compiler taking binary code for your C program plus binary code for std I would data center file means library. C library binary code plus OS library binary code. Yes, OS library. OS library. Yes, OS library contains input output functions. OS library contains input output functions. Okay. See, previously we discussed it. Previously we discussed it. See, library here. This is library. OS contains library. OS contains library. That library here. So that OS library is a collection of functions. Contains all the functions here. It contains all the functions. It contains all the functions. Okay. So it contains all the functions, right? Okay. So what happens here? Yes, GCC C language compiler just it will take tested.o binary code for binary code for your C program plus binary code for std I would add file and binary code for OS input output library, binary code for that OS library. By linking all of this in generating exe file, so finally this exe file contains binary code for C program, binary code for C library, std would address header file, and binary code for OS library. That is finally exe file. Okay. See here C program exe file. Prepared on Linux base. C program exe file prepared on Linux base. Then it contains yes, binary code for C program, binary code for C program plus binary code for C program plus yes, binary code for C program plus binary code for C library, plus yes, binary codes for OS library. OS library. Okay, binary code for OS library. Now here C program exe for prepared Linux base means Linux base library. Linux base library. That's it. Okay. C program exe file prepared on Linux base, prepared on Linux. C program exe file prepared on Linux base. Then it contains binary code for C program. Next, binary code for C library, binary code for Linux OS library. So OS library also part of exe file. OS library also links with exe file here, right? Okay, so this is called static linking. At the time of creation of exe file itself, see at the time of creation of exe file itself, at the time of creation of exe file itself, OS library links with exe file. At the time of creation of exe file itself, at the time of creation of exe file, yes, see at the time of creating this exe file only here, that OS library linking and generating exe file. So this is called static linking. This is called static linking, right? Statically linking database. Okay, see here OS library here. So OS library, yes, OS library library statically, yes, linking statically, yes, linking with exe file. So at the time of creation of exe file itself, linking that. Okay, let us take one more example. Suppose one more example here. One more example. C program exe file prepared on Windows base. Okay, then it contains binary code for C program, binary code for C library, binary code for Windows, binary code for Windows OS library. Okay, now Windows OS library here. C program exe file prepared on Windows OS. Then it contains binary code for C program, binary code for C library, binary code for Windows OS library. That's it here. Suppose one more example. For example, one more example. C++. Let us take C++. Suppose C++ program exe file prepared on Linux base. Then it contains here binary code for C++ program, binary code for C++ library, binary code for Linux OS library. Okay, so here OS library is a part of exe file. So finally here, so OS, yes, OS library. So OS library, yes, OS library is a part of exe file. It's a part of exe file. OS library is a part of exe file. Okay, now let us see this C program exe file. Okay, prepared in Windows OS. How it's working? How it works here? Let us see. Yes. So let us take this example here. This example. Let us take this example here. Yes, in this example here, C program exe file prepared on Windows OS. Then it contains binary code for C program, binary code for C library, binary code for Windows OS. Okay. So for example, test.exe file. For example, test.exe file prepared. Yes, prepared test.exe file. Yes, prepared test.exe file prepared on Windows OS. For example, test.exe file prepared on Windows OS. Then it contains Windows library here, Win library here. That Windows OS library here, Windows library. Okay, now this test.exe file running at different platforms. How it works? This test.exe file running at different platforms. How it works? Let us see here. Yes. Let us take different platforms. Yes, hardware. Suppose hardware. On top of hardware, this is OS. This operating system. So for example, Windows OS. On top of which Windows OS. So Windows OS with Windows library, Win library. Windows OS contains Windows library. So Windows library to communicate with the hardware components. Communicating with the hardware components. Okay. Yes. Next. Yes. On top of it, exe file running. Now test.exe file. So test.exe file. So you can test.exe file. Test.exe file. Just placing test.exe file. So this test.exe file, this exe file. So this is placing on Windows space. So test.exe file. Now test.exe file. Yes, when try to run this, what happens here? Now this test.exe file, it makes a call to Windows OS library here. So when you try to run test.exe file, yes, it makes a call to yes, Windows library. Yes, it will try to call to Windows library. Test.exe file. So test.exe file. Yes, prepared on Windows OS, right? Then it contains Windows OS, Windows library. When you try to run test.exe file, it will try to call Windows library. Yes, it's available. Just it's trying to call Windows library. Yes, available. Yes, using that library, it communicates with hardware components. Done. So successfully will execute here. It will run successfully here. So test.exe file. Yes, it will try to call Windows library. Yes, it's available. That Windows library is available. So it will call Windows library. Using Windows library, communicates with hardware components. Done. Successfully running. This is successfully running. Okay, right? Yes. Now let us take another platform for the same thing. Another platform. Suppose Linux base. Another platform Linux base. Linux base. Linux base. Another platform Linux. Linux base. Yes, Linux base kind of Linux library. Linux library. Okay. Same test.exe file. Same the test.exe file. Placing a Linux base. After placing a Linux base, when you try to execute this test.exe file, when you try to execute test.exe file, it will try to call Windows library because it's linked with Windows library. Already linked. Okay, at the time of creation of exe file itself, linked with Windows library. So it will try to call Windows library, but here it's not available. Okay, test.exe file is linked with Windows library, but here it's not available. It's a Linux library. So OS change, that library change, simply it fails. It fails. It won't work. So exe file is OS dependent. That's the reason here. Okay, OS file is yes, OS dependent. That's the reason here. Suppose one more platform. Okay, suppose Unix base. Same test.exe file on Unix platform. Yes, Unix platform. So Unix platform contains what? Unix library here. That Unix library. Unix library. Okay, so when you try to execute this exe file here, it will try to call Windows library, but here is not available. That library is not matching. Library is not matching. It fails. So exe file is OS dependent. Reason it contains OS library. That's a simple answer. Okay. So why exe file is OS dependent? Question is here. Yes. Why? Yes. Why exe file? Yes. Why exe file is OS dependent? OS dependent. Why exe file is OS dependent? OS dependent. Why exe file is OS dependent? Why exe file is OS dependent? Okay. For this simple answer, yes, it contains OS library. Yes, it contains OS library. It contains OS library. That's it here. So simple reason. So why exe file is OS dependent? Reason it contains OS library. Since it contains OS library, it's a OS dependent. That's it. So this is about exe file. This is about exe file. Now let us come to Java. Java. Yes. Java. Java. If it is Java, how it's working here? Yes. If it is Java, how it's working? Okay. Yes, like C programming Java. Yes. After compilation generating dot plus file. So what is dot plus file? Java dot plus file. Yes, after compilation. See, after compilation. Yes, after compilation. Yes, result file is what? Result file is a dot plus. Dot plus file. Yesterday I showed. After compilation, result file is a dot plus file. After compilation, result is dot plus file. So what is dot plus file? So dot plus file contains what? Okay, now question is get dot plus. Okay, dot plus. Dot plus file contains what? Dot plus file contains what here? So dot plus file contains what? Okay, yes. Dot file contains, sorry. Dot file contains what? Okay, dot file contains what here? Okay, see, same, let us take same example like this. Like a C program, Java program. Yes, Java program. Yes, in place of C, now Java program. Java program. See Java program dot class file. Java program dot class file. Java program dot class file. See Java program dot class file. Java program dot class file prepared on Windows page. Then it contains what? Same point here also, right? Like C program exe file, Java program dot class file. Like C program exe file, Java program dot class file. Java program dot class file prepared in Windows page. Then it contains what? Yes, bytecode, not binary code. It's a bytecode. It's a bytecode for Java program. Bytecode for Java program. See, binary code, bytecode difference. Binary code is a system understandable language. Binary code is a system understandable language. Bytecode is a JVM understandable language. How exactly bytecodes? Yes, we'll discuss. I'll explain. Next class topic. Okay. About bytecode, we'll discuss in next class. Yes, with the JVM topic, I'll explain. We have separate class on JVM. Okay, there is separate topic on JVM. That time I'll clear this. See, JVM topic. Here this JVM topic separately. That time we'll discuss about bytecode. Yes, all this Java installation topic. This Java installation, Eclipse working on all this. Yes. Yes, after finishing Java installation, after writing first program, next JVM topic. I think JVM topic it's Monday. Monday, how JVM is working internally here, how dot class file is working here. Okay, bytecode verifier, how it's working, the bytecodes. So about these bytecodes, yes, next class, next coming classes. Okay, yes. So you can, so Java program, yes, dot class file prepared in Windows first, then it contains bytecode for Java program. Next bytecodes for Java library. So bytecode for Java library. See bytecode binary code. Binary code is system understandable language. Zeros ones format. Okay, zeros ones format. Bytecode is a JVM understandable language. Okay, so bytecode is a JVM understandable language. Okay, so bytecode for Java program. Bytecode for Java library. Next binary code for OS library. No, this part no. Only this is. Okay, so bytecode for Java program. Next, bytecode for Java library. See, Java library also developed in Java. Java library also developed in Java. So simply purely Java program. So dot class file. So dot class file. Yes, dot class file. So dot class file. Dot class file is a purely Java program. Purely Java program. Dot class file is a purely Java program. Okay, dot class file. See, dot class file is a purely Java program. Purely Java program. Okay, suppose for example here, tested dot class file. Tested dot class file. For example here, tested dot class file prepared on Windows base. Windows base. Yes, Windows base. Tested dot class file. See, tested dot class file prepared in Windows base. Then it contains what? It contains what? Yes, it contains what? Yes, only just Java program code. Yes, Java bytecode library. Okay. Yes, see this. Yes, then it contains bytecode for Java program plus bytecode for Java library. Okay. Yes, it does not contain any OS library here. Okay. Yes, it does not. Yes, it does not. It does not contain. Yes, it does not contain any OS library. Okay. It does not contain any OS library. Okay. Yes, it does not contain any OS library. Okay. So dot class file prepared in any ways. It contains only this is. Okay. See dot class file. See dot class file prepared on any ways. On any ways. Yes, it contains only Java program codes and Java library here. Okay, yes, tested dot class file prepared on any ways. It contains only Java program codes, only Java program codes plus Java, Java library. That's it here. Okay, it contains only these two things. So OS library is not a part of dot class file. Okay, the tested dot class file prepared in any ways maybe Windows based, Linux based, Unix based, OS may be anyone. Okay, OS may be anyone, but the dot class contains only Java codes. Okay, it contains only Java codes. Yes, it contains only Java codes. Java codes. Okay. Yes, it's a pure Java program. Dot class file. So dot class file is a pure Java program. Dot class file. Okay, dot class file. Simply dot class file. So dot class. So dot class file is a pure Java program. Pure Java program. Pure Java program. That's it. So this is pure Java program. Okay, fine. Now dot class file running at different platforms. How it works? Dot class file. So dot class file. So tested dot class. For example, here tested dot class file on different platforms. Let us take different platforms here. Yes. Yes, how that behaves. Let us see. Different platforms. So dot class file on different platforms. On different platforms. How it's working. So dot class file on different platforms. See. So first Windows platform. Yes, first Windows base. Windows base. So that Windows base contains Win library. Win library, right? Win library. So hardware on top of it Windows base. No tested dot class file. So tested dot class file placing on tested dot class file, right? Test dot class file. So tested dot see this tested dot class file. Tested dot class file prepared anywhere. Now moving to Windows base. After moving to Windows base here, now running tested dot class. So when you try to run this, what happens here? This tested.class file. Just to run this tested.class file, what is required here? To run the tested.class file, what is required here? See, previously we discussed it. Previously here, previous class, yes, in various concepts. See, every program, C program or C++, Java, Hadoop or database Python, all of the every program, first of all, it should link with various libraries. That point we discussed it. All these programs, first of all, linking with various library, just linking with various library. Of linking with various library, then communicates with hardware components, right? Yes, that compulsory requires. Yes, every program has to link with various library. See this. Every program has to link with various library before going to run. Compulsory it has to link. Suppose if it is C and C++, if it is C and C++, at the time of creation of exe file itself, linking. That is called statically linking. C and C++ is statically linking. C and C++ is statically linking. C and C++ is statically linking. Okay, statically linking. At the time of creation of exe file itself, linked. At the time of creation of exe file itself, linked. So that is statically linking. Okay. Yes, in Java, even Java program also has to link with base library or Python. So all the programs, every program has to link with base library. So every program has to link with base library. See, in this case here, see here tested.class file, tested.class file. So before going to run tested.class file, it has to link with base library. But here test.class file don't have any base. It's a plain Java program. Yes, it's not linked with any base library. Now this tested.class file has to link with Windows OS library. So tested.class file is running on Windows library. So sorry, tested.class file running on Windows OS. Okay, tested.class file running on Windows OS. To run on Windows OS, that has to link. The tested.class file has to link with OS library here. Who will link it? Who will link it? Someone has to link it. Someone has to link here. So between tested.class file and Windows OS, one more layer comes to picture. Now one more layer comes to picture. So what is that layer? Yes, anyone can guess it? What is that layer here? So what is that layer? So between tested.class file, Windows OS. So one more layer come to picture. So what is that layer here? Anyone? Someone has to link. Someone has to link tested.class file with Windows OS library. Who will link it? Yes, one more layer comes to picture. What is that link here? So what is that layer? Anyone can you guess it? Yes, anyone can you guess it? No idea. Anyone? Anyone? No response. Yes, JVM come to picture. This JVM, Java Virtual Machine. Java virtual machine. The Java virtual machine comes here. Okay, so you get tested dot class file. So first of tested dot class file moving on to Windows Base. After moving on to Windows Base, here this JVM. So JVM taking tested dot class file. JVM taking tested dot class file and links with Windows Base library. Okay, so JVM taking tested dot class file. JVM taking tested dot class file, just linking with Windows Base library. Linking with Windows OS library. So once linked with Windows OS library, then it communicates with hardware, then executes. So JVM comes to picture. Okay, yes, if OS is Windows OS, JVM taking tested dot class for links with Windows library. That means before going to run, yes, means at runtime. At runtime, linking OS library with your Java program. Okay, so the Java program links to OS library at runtime. So it's a dynamic link. Dynamically, not statically linking. Suppose if it is linking at the time of creation of dot class file, that is called statically linking. Now this is dynamically linking here. At runtime, this is okay. At runtime here, yes. If it is C program exe file, C program exe file, yes. C program exe file statically linking. At the time of creation of exe file itself, linking. But when come to dot class file here, see at runtime links to Windows library at runtime. So this runtime at runtime tested dot class file at runtime tested dot class file link to yes Windows OS library here. So JVM taking tested dot class file, JVM taking tested dot class file, just linking with Windows library. So once linked with Windows library, executes finally generating output. That's it. Okay. So this linking is at runtime. This linking happens at runtime. So it's a dynamical linking. Not only Java, even Python also. Python also dynamical linking. So it depends on OS. Depends on OS. Dynamically linking here. Okay. So you can link to this Windows OS library and execution generating out here. So once linked with the OS library that communicates with yes hardware. So generating output. That's it. So this is. So next let us take another platform. Another platform. Yes, Linux platform. Another platform. Linux platform. Linux. Let us take Linux base. Linux base. Okay. Now tested dot class file. Same tested dot class file, just moving at Linux base. So once move to Linux base here, on Linux base, here this is Linux base. Linux base. Linux base. So you can Linux base library here, Linux library here. Linux base can Linux library. Now Linux JVM. Here Linux JVM taking tested dot class file. Linux JVM taking tested dot class file links with Linux base library. Just linking. Okay. So Linux JVM taking tested dot class file links with Linux base library here. So once linked with OS library, then communicates with hardware component. That's it here. So JVM takes care of linking your tested dot class to current OS library. Yes, if OS is Windows OS, if OS is Windows OS, tested dot class file yes links to Windows OS library. Suppose if OS is Linux based, linking to Linux based library. So this tested dot class was independent platform. Yes, independent platform. Okay, this tested dot class file does not contain any OS library. Suppose if dot class file contains OS library, it becomes yes OS dependent. If dot class file contains OS library, it's OS dependent. But dot class file don't have any OS library. It's a purely Java program. Purely Java program. Yes, at runtime depends on OS. If OS is Windows OS, then linking with Windows OS. Same dot class file moving on to Linux OS. After moving on to Linux OS, then Linux links to Linux OS library. Depends on current OS. Depends on OS that link changes. Okay. If OS is Windows OS, links to Windows OS library. If OS is Linux OS, then links to Linux OS library. Suppose let us see one more platform. Suppose one more platform. One more platform. One more platform. See one more platform. 1 second. Yes, another platform. Test.class file or Unix base. Or Unix base. Unix base with Unix library. 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 Okay. Now on Unix base, this is JVM. Now this JVM taking tested.class file. Okay, taking tested.class file links with Unix library. Once linked with Unix library, communicates hardware components. That's it here. Okay. Yes. So you get dot class file is a common for all operations. Same for all operations. Okay. Yes. If OS is Windows OS, then JVM links with Windows library here. If OS is Linux OS, yes. See, every OS contains its own JVM. JVM is different. See here, every OS contains JVM. Yes, Windows OS JVM, on Linux OS JVM here. Yes, Unix OS JVM. Okay, correct? Yes, if OS is Windows OS, then Windows JVM taking dot class file links with Windows OS library here. Yes, yes, if it is Linux OS, Linux JVM taking dot class file links with Linux OS. Okay, correct? Yes. So if it is Unix OS, links with Unix library. So it depends on OS. So even OS change, no problem here. Even OS change, no problem here. That links to current OS. Depends on OS, automatic linking here. Who will link it? JVM. So behind of this JVM is there. So JVM takes care of linking at runtime here. So JVM, yes, makes it Java as independent platform. So behind us, how Java made us independent platform. So behind of this JVM is there. So JVM, yes, JVM makes it Java as independent platform. Dot class file is independent platform. Okay, so you can dot class file don't have any OS library. Suppose if it is containing OS library, it's OS dependent here. Yes, if it is containing, see if it is containing OS library, if it is containing OS library, it's a OS dependent. It's a OS dependent. Okay, but it don't have any OS library. Yes, don't have any OS library. Okay, depends on OS that link changes. Depends on OS that link changes at runtime. It's a dynamical linking. It's a dynamical linking. So that's the reason Java program is independent platform. So tested dot class file is independent platform. Okay, fine. Here doubt is here. Some doubt. JVM is it part of OS? JVM is it part of OS? That's a question here. JVM is it part of OS? No. JVM is not a part of OS. JVM is not a JVM is not a part of OS. Okay, then how to get JVM here? Yes, JDK software. Once JDK software installed, that getting JVM automatically. So you get JDK software installing on Windows OS, JDK software on Linux OS, next JDK software install Unix OS. So on every OS you have to install JDK software. So once JDK installed here, then getting JVM. Otherwise, you can't get JVM. JVM is a part of JDK. So from the JVM coming from the JDK, the JDK Java development kit, Java development JDK should be installed on the OS. JDK should be installed on OS. So once JDK installed, then getting JVM. So that JVM takes care of linking your dot class file with current OS libraries. That's it. Next, one more point here. One more point. Java program is independent platform. Java program. Java program is independent platform. Java program is independent platform, but JVM is a platform dependent, OS dependent. Java program is a independent of OS, but JVM is a OS dependent. JVM is a OS dependent. So why JVM is OS dependent? Reason, it's a C++ exe file. JVM developed in C++. JVM developed in C++. Okay, JVM developed in C++. Okay, yes. JVM developed in C++ is a C++ exe file. JVM is a C++ exe file. So because of exe file, it's OS dependent. Okay, see, this is Windows JVM, right? This Windows JVM exe file, it's exe file. It's exe file. So Windows JVM contains what? Windows library. Linux JVM contains what? Linux, it's exe file. So what is exe file? Exe file contains OS library. Exe file contains OS library. Exe file contains OS library. Now here Windows JVM contains Windows OS library. Linux JVM contains Linux OS library here. Yes. So like Unix JVM contains Unix library. Yes, JVM it's exe file. Since it's exe file, it's a OS dependent. Okay. So Windows JVM is having Windows OS library. Yes, next this is with Linux library. Yeah, this is with Unix library. So the JVM contains library here. Okay, so here, yes, Windows JVM is having knowledge of Windows library so that it can link to Windows library. See, Windows JVM contains what? Windows library. Windows JVM. Here, Windows JVM contains Windows OS library. Because Windows JVM contains Windows OS library. Since it contains Windows library, yes, it can communicate with Windows OS easily here. See, Windows JVM contains Windows OS library. Means Windows JVM is having knowledge of Windows OS library. Since it is having Windows OS library here, then it communicates with Windows OS. Like similar Linux JVM. Linux JVM contains Linux library. Linux JVM contains Linux library. Since it contains Linux OS library here, it can communicate with Linux library. So Windows JVM is having knowledge of Windows library so that it can communicate. Next, Linux JVM is having knowledge of Linux library so it can communicate. Similarly, Unix JVM is having knowledge of Unix library so it can communicate. So that JVM is having knowledge of library region that JVM contains OS library. JVM is exe file. JVM is exe file. That exe file contains library. So if that exe file is having library here, it can communicate with Windows library easily. Okay. So Java program. See, Java program is independent platform. Java program is independent platform, but JVM is OS dependent. JVM is OS dependent. Okay. So since JVM is OS dependent, JDK also different JDK getting here. JDK also changes. So JVM is OS dependent. JVM is OS dependent. So automatically JDK also changes. Yes, Windows JDK different, Linux JDK different, Unix JDK different here. Same JDK you can't, same JDK you cannot install on different operating systems here. Same JDK cannot install. So for every way, separate JDK is available. For every way, separate JDK because JVM is OS dependent. JVM is OS dependent. Okay, let me show JDK. JDK for different operating systems. See JDK. Sorry, not in box. Yes, Google. Yes, downloads. So downloads of JDK 1.8 or 1.7 something like this. Okay, JDK. See JDK. See this JDK. JDK product. The JDK here. Linux base. Linux platform. Yes, Mac OS. See, these are JDKs downloads. JDK for Linux. These are all JDK for Linux, different Linux operations. Linux also different operations are there. Okay, Linux 64-bit, Linux x86 like this here. Okay, next step. Yes, Mac OS, JDK for Mac OS, JDK for Solaris. Okay, next JDK for Windows OS, JDK for Windows OS. Okay, yes. If you want to work on Windows OS, this one, last one you have to download, Windows 64-bit. This one, JDK 8U2 Windows, this one, last one on Windows OS. Windows, yes, 64-bit OS, Windows 64-bit. So last one you have to download for Windows OS. Suppose Linux OS, Linux 64-bit, this one, Linux, one second, tar file. Yeah, this is a tar file. Linux, tar file. This is for Ubuntu Linux base. Tar file for Ubuntu Linux base. Next RPM, Red Hat Pack Manager. This is for Red Hat Linux base. This is for Ubuntu Linux base. This is for Red Hat Linux base. Red Hat Linux base. Ubuntu Red Hat like this. Okay, so different Linux applications. Okay, so different JDK software you have to download. Different JDK software you have to download it. So the JDK is a OS dependent. JDK also OS dependent. Like JVM. JDK also OS dependent. So different JDKs you have to download. Different JDKs, not same case. Different JDKs you have to download it. That's it here. Okay. Yes. So this is how Java made us independent platform. The reason is this. Okay. This is about independent platform. Okay. Exe file is OS dependent. Why exe file is OS dependent? It contains OS library. Exe file contains OS library. Since exe file contains OS library, it's OS dependent. Yes, when come to Java program don't have any OS library. Okay, plain Java program, simply plain dot plus with a plain Java program. That Java program links to OS library and runtime. It's a dynamic linking. Even Python also same. Python script also don't have any OS library. Python script also linking to OS library at runtime. Python, Java both are independent platform. Reason these programs linking at runtime. See, any program which is linking at runtime, dynamically linking, if it is dynamically linking, that is independent of OS. Any program which is linking at runtime, that is dynamically linking, that kind of programs are independent of platform. Okay, statically linking means let's say OS dependent, OS dependent. Okay, right? Yes. Now, what is exactly exe file? What is dot class file? What's the difference between these two? Exe file, dot class file, differences. Let us see the differences here. Exe file, dot class file. Okay, see, very clearly prepared. Whatever we discussed, same points prepared here also. In document. Exe file. About exe file and dot class file. 1 second. The differences. Difference between exe file and dot class file. What's the difference here? Let us see. 1 second. Let me have some water. Yes. See this. Exe file dot class file. What's the difference? Exe file dot class. Difference between exe file dot class. What's the difference? See. First difference. Exe file is a binary code file. Binary code. Binary code. Dot class is a byte code, right? Exe file is byte code. It is a system understandable language. Exe file is a byte code file. It's a system understandable language. Yes, dot class. It's a byte code file. It's a byte code file. It's a JVM understandable language. That's the main difference. First difference. Exe file is a binary code file. It's a system understandable language. Binary code is a system understandable language. Dot class, it's a byte code. Byte code is a JVM understandable language. JVM understandable language. That's the first difference. So next step. So what is exe file? Exe file contains what? See, exe file, it contains program codes plus software library plus OS library. All of these things. Okay, it contains program codes. Okay, it contains exe file contains program codes plus software library plus OS library. That is exe file. That's C program codes, C software library, and Windows or Linux OS library here. Right? What is dot class file? Pure Java program. Dot class file is a purely Java program. It's a pure Java program. Don't have any OS library. Don't have any OS library. It's a pure Java program. Purely Java program. Don't have any OS library. So next difference. Right? Okay. So next, same these points already explained. But now I'm comparing, just comparing. Already these points discussed. Just I'm comparing now here. Okay. See, exe file prepared for specific OS. That means here, suppose exe file prepared in Windows OS. That kind of what Windows library means already Windows library linked. Linking is over. Means already prepared file. Okay. If exe file prepared in Windows OS, that links with Windows library here. Means already prepared. Exe file is already prepared. Again, linking is not necessary. Already linked. Already prepared file. Suppose exe file prepared a Linux base. Already linked with Linux base library means already prepared file here. Okay. So exe file is a prepared file for specific OS. Exe file is a prepared file for specific OS. What is dot class? Is not a prepared file. No, it's not a prepared file. Just plain Java program that is not prepared for any OS. Okay. Dot class file is not a prepared file here. It's not a prepared. Okay. Exe file is already prepared for specific OS. Reason that already OS library linked. So OS library already linked with exe file means yes, it's already prepared file here. But dot class is not a prepared file. Yes, not linked. It's a yes, not a prepared file. Okay, right? Next difference. Next difference here. See, exe file. OS library statically linking with exe file. Exe file, yes, at the time of creating exe file, okay. See, OS library is a statically linking. So OS library statically linking with exe file at the time of creating exe file. Okay, yes, when come to dot class. What is dot class file? That OS library dynamically linking with dot class file at runtime. So runtime, right? See, OS library dynamically linking with dot class file at runtime. So it's runtime linking at runtime, right? So dynamically linking. That is dynamically linking. Dynamic runtime linking means dynamically linking. Okay. Yes. Next, another difference here. See, exe file is already prepared one. before moving to OS. Already preparing and running directly here. Already prepared. But dot class file is not a prepared. Dot class is not a prepared file, right? See, after moving on to OS, JVM prepares as per current OS. See, after moving on to OS, yes, here. So dot class file after moving on to Windows OS here, Windows JVM taking dot class file links with Windows library. That means preparation is done. So dot class file after moving on to OS, as per the current OS, that links takes place. That linking takes place. Means runtime preparation is not a prepared file. Yes, dot class is not a prepared file. After moving on to OS, then prepares as per the current OS. As per the current OS library. Okay. Yes. See here, dot class file. Dot class file is not a prepared file. After moving on to OS, JVM prepares as per the current OS. JVM prepares as per the current OS. So here exe file is already prepared file. Exe file is a prepared file for specific OS, but dot class file is not a prepared file. Dot class is not a prepared file. After moving on to OS, then prepares as per the current OS. Okay. Yes. Next difference. See, exe file executes faster than dot class file. Why? What's the reason? See, exe file is already prepared. Exe file is already prepared. That exe file contains what? Binary code. Exe file contains binary code means system understandable language. Exe file is already in system understandable language. Next, already linked. Yes, both were done. Already converted file here. Already conversion is done here. So binary format. Exe file already in binary format and also already linked with OS library. Everything is already done. It's already prepared file. Again, preparation is not necessary here. Already prepared. Yes, already binary code linked with exe, linked with OS library. So that's the reason executes faster. Yes, when come to Java program, dot class file. So what happens here? Dot class file. See dot class file. See the dot class file. So what dot class file? Just like yesterday's we discussed here. Dot class file. First statement, next statement. So next statement. So next statement dot class file. So it's a bytecode file. Dot class bytecode file. Dot class file. So next statement. So next statement. All the statements. All the statements. Okay. Yes. Right. Yes. Now what happens here? If this dot class file. Okay. Yes. This is Java interpreter. Java compiler. Yes. Java error checking with the compiler. If no error, then generating dot class file. The dot class file executing with the interpreter at runtime. Interpreter. This interpreter. Now interpreter come to right. Interpreter. Interpreter comes to picture. Interpreter. Interpreter comes to picture. So what happens? This is bytecode. This is bytecode. This is bytecode. That line is a bytecode, right? That bytecode. So this bytecode. First of all, this bytecode will be given to interpreter. Interpreter taking bytecode. Bytecode. That bytecode is converting into binary codes. Okay, that bytecode simply here. Yes, interpreter taking bytecodes and generating binary codes. Generating binary codes. So interpreter taking that complete bytecodes. Yes, converting binary codes. Generating binary codes. Okay. So bytecodes is input for the interpreter. So interpreter taking the bytecodes, converting into binary codes. After converting into binary codes, that binary codes, this binary code, next step is linking with OS library. Links to OS library. Here there is a OS library. So OS library, linking with OS library. Linking with OS library. Just linking. Linking with OS library. Linking with OS library. So what is happening here? Yes, there are two operations, two jobs. So one is to convert bytecode to binary format. That binary format linking with OS library. So first statement converting to binary code links with OS library. Similarly, second statement, same process. Second statement given to that interpreter here. Generating binary code for second statement that links with OS library. Okay. Next third statement. So line by line. Yes, interpreter is line by line. Interpreter taking next line, next statement. So next statement given to interpreter. Same binary code generation. That binary code linking with OS library. That's it. So all this happens at runtime only here. Runtime, what is happening here? Converting it to binary code. First task is converting it to binary code and linking with OS library. These two things are happening at runtime only. In Java, these two things are happening at runtime only. But if it is exe file, everything at the time of creation of exe file itself. Exe file, already binary code file. Exe file is already binary code file. Exe file is already linked with OS library. Everything is done at the time of creation of exe file. Directly execution, directly running exe file, directly running exe file. When come to dot class file is not a prepared file. At runtime converting it to binary code and linking with OS library. This task is a preparation task. Preparation. That code preparing as per the current OS. So that runtime happens here. Code preparation runtime here. Preparation means converting it to binary code. That binary code links with OS library. That means preparing at runtime. Since Java program preparing at runtime as per the current OS, it will take some time here. Preparing and running. Every statement preparing, every statement converts into binary code and linking. Next statement converts into binary code, linking. Next statement convert into binary code, then linking. So this is happening at runtime. Since it's happening at runtime, it's slowly executing. Compared to exe file, Java program executing slowly. Yes. To improve the performance of Java application, yes, many strategies introduced in Java software. Yes, like multi-threading concepts, like collections concepts. Okay. Yes, like that, many things introduced. Next, garbage collections, using collection components, next multi-threading, like that. So many strategies, yes, following inside of the applications here to improve Java application, right? Yes. So here, yes, dot class file executes slower compared to exe file. Okay. Exe file execution is faster. Okay. See, to run, yes, exe file executes faster than dot class file. Since dot class file preparing at runtime is executes slowly than exe file, slowly executing. Okay. Not much slow, little bit slow. Compared to exe file, Java program is little bit slow here, little bit slow. Okay. Yeah, that is negligible. That can be considerable. That's not an issue. Compared to Java features, compared to advantages, so that disadvantage is minor, negligible. Okay, that disadvantage that can be considerable compared to development efforts, maintenance efforts, and features. Many features. Project development easy, maintenance easy. Okay. Yes. Next, many features available with Java. So different kind of, so many, yes, requirements you can achieve with Java. So compare with advantages, these disadvantages, simple. Very that can be considerable. Okay. So the exe file executes faster than yes dot class file. So since dot class file preparing at runtime, yes, executes slowly than exe file. Okay. Next, one more important difference here. Yes, one more important difference. Maybe asking this question. Maybe asking this question also. Yes. See, exe file, project exe file, right? C program exe file. Yes, to develop the C program exe, first of all, C software required. See, on Linux machine, yes, I have installed C software. So C software available, C compile available, C software available, C compile is available. So using that, develop C project, right? The project exe file, same project exe file, moving on to another Linux. Currently, this Linux is running. Ubuntu one is running. First Linux space. Same exe file, that project.exe, that exe file, project exe file, same project exe file can move to similar kind of ways, not different operations. Yes, next, this is one Ubuntu. On Ubuntu, exe file prepared. Same exe file prepare. Yes, running at another Ubuntu OS. Yes, it will run because similar ways. Similar ways, it will run. Suppose same exe file, if you're running at Windows page, it fails. Windows page fails, Linux fails. But similar ways, no problem, no issue. Similar ways, no problem, no issue. Is running here. And similar ways. Okay. Now here question is here. See, on first Linux base, C software installed and project developed. Project developed, right? Not these projects running on second Ubuntu. To run on second Ubuntu, yes, is it required C software or not? Okay, in first Ubuntu is C software installed and C project developed. Same project moving on to second Ubuntu is can I run directly or similar ways? Similar ways we can run it. Now is it required C software? No, not necessary. Okay, yes, on second Ubuntu is directly that exe file can be executed. That exe file can be executed. Yes, again C software installation not necessary. If it is similar ways, here, C software is not necessary. Only at the time of development, only at the time of writing program, yes, writing program, compilation and generating exe file. Once exe file generated, C software not at all required. Okay, that exe file you can place on similar ways, similar kind of ways. You can run it directly without C software. But when come to Java, yes, to run dot class file, okay, to run dot class file, series dot class file, running dot class file Windows OS, JVM requires. Same dot class file running on Linux, JVM requires. Okay, running on yes, other system, the JVM requires. JVM required, right? How to get JVM? JDK. That means to run dot class file compulsory JDK should be installed. Even project development completed here. Project development completed. Everything is completed here. To run dot class file compulsory JDK should be installed. Okay. So Java test dot class file prepared on Windows space. Okay. After moving to another Windows space. Okay. So when moving to another Windows space, on another Windows also must have the JDK. Otherwise cannot run because at runtime JVM work. Without JVM, without JV help, dot class file never running. It's not a prepared file. Exe file is a prepared file. Exe file is already prepared file directly running. Mean that software not necessary. C software is not necessary. But when come to Java, Java dot class file is not a prepared file. So that should be preparing by the JVM. So how to get JVM here? Yes, JDK software. Okay, to run the dot class file compulsory Java software required. Without Java software, Java program never running here. If it is exe file, similar ways running directly here. C software not necessary. But dot class file, to run the dot class file, compulsory Java software, JDK should be installed. Okay, JDK should be installed here. Okay, yes. See this to run, yes, to run dot class file, to run dot class file, JDK should be installed on OS, otherwise you cannot run. So this is difference between exe file dot class files. Okay, see very clearly prepared, very clearly explained. Exe file dot class file differences, independent of platform, very clearly prepared. Expand here. Okay, see generally here, yes, to explain this concept, embedded C knowledge required. Generally, no trainer will explain this kind of things. This kind of depth, in this much of depth, no trainer will explain you. Simply independent of platform means running on any ways. Simply only 1 or 2 points I will explain, that's it here. But almost one class taken. Not one class actually here. To understand today topic, last 2 classes are prerequisites. Yes, I have prepared you. In last 2 classes. Last 2 classes explanation is a prerequisite for today topic. Okay. So independent of flat, to understand this independent of platform, last 2 classes explained. Last 2 classes, today class, almost 3 classes explained. Independent of only one that feature here, independent of platform, to understand it, all that everything clearly one by points was prepared, explained very clearly. Okay, but no trainer will take this much of risk. I know that because they don't know about embedded C knowledge. Directly they are working on Java here. Okay, even they don't have any real-time experience. Learning somewhere, teaching somewhere. Okay, yes, because of I have all that real-time experience like Linux OS experience, Linux knowledge. Okay, next embedded C knowledge and Java experience and all because of that only. Yes, I'm able to explain this. See, my first 4 years is embedded C. Later changed to Java. Okay, next. Now presently I'm working on Hadoop and big data also. Hadoop and big data is Linux based. So because of that experience only, by combining all this experience, yes, very clearly explains. So this is about independent platform. Okay. Yes. Next, other features. Portability, they are very simple features. We'll see next year. So tomorrow class, installing Java. How to install Java? So tomorrow class, installing Java software, installing Eclipse. Next, how to develop the applications in Eclipse. Steps to develop applications in Eclipse here. So installing Java, yes, installing Java and Java environment setup. Installing Java, Java environment setup. Next, Eclipse setup, and next, developing first application Eclipse. Okay, tomorrow we'll discuss that all the concepts. Okay, that's all for today. Yes, any doubts? Yes, guys, any doubts? Any doubts? Yes, if no doubts, let us wind up session for today. For today enough. Yes, we'll continue for tomorrow. So tomorrow class, Java installation, environment setup, and next Eclipse setup. Tomorrow also same link, no change in link. No change in link. Okay, yeah. So that's all for today. Yes, next one more thing here. See, one more thing. See, in WhatsApp group, every day I'm sharing link for watching our class. Your daily link sharing. Okay, yesterday's class also shared in WhatsApp group. Okay, just open that, download and watch it. Open that link, download everyday video. That link I'm sharing. Okay, yes, drive access. Yes, today night or tomorrow morning I'll give the drive access. Drive access tomorrow. Okay. Yes, see, already I have given WhatsApp number. Yes, WhatsApp number already given. Please share your details. Okay, share your details to my WhatsApp number. Okay, WhatsApp number. Share your details so that I can add to group. So first of all, share your details. Without sharing, how I can add? So share. Please share your details. Your name. So what's your name? Okay. Next, what's the course you attending here? Course, that information. Okay. Next, time. What's the time you attending here? Next, what's your Gmail ID? Gmail ID. Gmail ID required. Please share this information. I'll add to group. Okay. Yes, in group already communication is going on. WhatsApp group. Communication going on. Yes, some persons even personally also interacting with me. They're asking doubts, their career doubts and all that. See here these doubts, students' doubts. Yes, your match. Yes, 5 p.m. See, some communication already going on. See this link, session 1 link, session 2 link. Yes, yesterday session 3, today session 4 link. Today session 4 link. Yes, by 10 o'clock I'll say, because this record has to process. To process record, it will take some time. Okay. Yes. So this is my WhatsApp number. Still anyone pending are there? Please share your details. Yes, you can get every day. That links. Tomorrow drive access I'll give you. Okay, not sharing link every day here. Tomorrow drive access, drive level. Already drive created for your batch. Drive. Let me show the drive also. Yes, sir, drive. So this is Google Drive. Yes, 5 p.m. batch, Google Drive. See, 3 sessions already uploaded. Okay. Yes, Google Drive. From that you can see directly here. Direct. Okay. So Google Drive. Here it's already uploaded. Yes, today video I'll upload by 10 o'clock. Okay, next. Yes, in WhatsApp also I'll share that. The daily recording link separately. Separate link. Now here what I'm doing here. Right click, get link. I'm getting this link. I'm sharing with you. Get link. So that link is generating. Copy link I'm sharing. But from tomorrow what I will do, I'll do drive level access. Sharing drive. sharing drive. Okay, drive level access I will give tomorrow. Okay, so once drive access is given here, once drive level access is given, directly can access. Daily link not necessary here. Directly can open drive, you can see. In your drive, you can see all that. Daily videos you can see. Okay. Yes. Yeah, that's all for today. Still any doubts? Still any doubts? Yes, this is WhatsApp number. Share your information. I will add the group number. Right? Yeah. Okay. Yeah. So that's all for today. So thank you guys. See you tomorrow. Tomorrow installation class. Thank you.